we describe a system capable of robust, real-time learning and training for synthetic characters. Here we show an example creature built with our system. The pup naturally experiments with different behaviors from its behavioral repertoire. We interact with the pup using this pair of hands. The pup can be trained using a technique for real animal training known as clicker training. This click acts as a reward marker, pinpointing the performance of a desired behavior. In real dog training, the click is associated with receiving a food treat. If we click whenever the pup sits, the frequency of the sit behavior will increase. Once the pup is sitting frequently, we can begin to associate a verbal cue with the performance of the sit behavior. Let's look behind the scenes to see what is involved in this kind of learning. The pup's behavior system is composed of a number of basic action tuples. Each action tuple has a value associated with it. When we reward the performance of an action by clicking, the value of the action goes up, and the frequency of its performance increases. Once an action has obtained a sufficiently high value, it becomes a candidate for a process that we call innovation. If we reliably associate a cue with this action, a new action tuple is created. This new action tuple will only be performed in the presence of the cue. This pup has discovered a new relationship between perceptual states and actions. This is an example of state-action-space discovery. In performing this kind of learning, the pup has also discovered a new cue, the utterance sit. This is a state space discovery. The pup represents these cues and the rest of its world using a structure called the percept tree.
Good dog.
For example, whenever the pup hears a sound,
Beg.
his speech percept becomes active.
Sit.
The pup represents and classifies auditory patterns within this perceptual framework. Now we'll take a closer look at a typical training session. This graph shows the frequency of the pup's actions while interacting with the trainer. Before training, the pup's actions are equally frequent. As we begin to reward the sit behavior, its frequency increases. As we introduce the verbal cue, the frequency of spontaneous sitting decreases, while the frequency of sitting when we say sit stays high. If we stop saying sit, the pup behaves as it did before training. When we resume our vocal command, but stop rewarding the pup will gradually stop sitting in response to the cue. Finally, we'll look at some examples of action-space discovery. The pup can be trained to perform actions through a process known as luring. During luring, the pup tries to follow the hand with its nose. Thus, we can guide the pup's exploration of its motor space by moving the hand. In addition, if we reward a novel motor trajectory, a new top-level action is added to the pup's behavior system. This new action can be subsequently associated with a verbal cue, just like any other of the pup's actions. For real animals, the form of an action is often very important. We can teach the pup the correct form of an action through a process known as shaping. Here, the pup naturally experiments with different forms of its shake behavior. If we reward the pup for higher and higher versions of this shake behavior, he will soon learn to shake high reliably. In this video, we have shown a character who possesses the ability to learn at a number of different levels. We believe that the ability to learn in these ways adds a new and rich dimension to interactive synthetic characters.